tangent today. We talked about sine, we talked about cosine. Now we're going to talk about tangent. So just kind of to review a few old concepts in geometry. Tangent is opposite over adjacent. So, like if this is my triangle, and let's say this is 3, this is 4, this is 5, I would write tangent of theta equal to what would opposite over adjacent be? 4 over 3, yeah. Right. And in a unit circle, so let's kind of look at the same concept in a unit circle. So if I have, let's say this is my angle, my ray. I could make this a triangle. Let that be my angle. So tangent, so the opposite side is this one going up and down. Okay? And on a coordinate plane, that is this point right here, like this distance from there to there is your y value. Right? The distance from like the x-axis up, that is your y value. And then this distance is your x. So if you're finding tangent, it's opposite over adjacent. So it's y over x. Two things this relates to. I'd actually never had it put this way, but I'm going to because that was kind of like in our standards for pre-cal. It's like the slope. The slope of this line is rise over run. So tangent could be considered the slope of the ray. Makes complete sense. Slope is rise over run, or it's your change in y's over your change in x's. We also know sine or cosine, one of those is your y value of that point. Which one is it? Sine. And cosine is, or x is cosine. So tangent can also be written, and this is the one that's more common, as sine over cosine. So to find tangent, you take the sine divided by the cosine. So you're still going to need your unit circle, but you don't just get to look at the unit circle and know straight off what sine or cosine is. You're not just picking out a point and there's your number. You have to divide the y or the sine by the x or cosine. And in fractions, we know that the denominator cannot be what? You can't have a fraction with the denominator of 0. So cosine can't be 0. If cosine is 0, there's no tangent. It's undefined, which we're going to call a vertical asymptote. So let's just do some basic problems. If you're asked to do tangent of pi over 4, we first have to find sine of pi over 4 and cosine of pi over 4. And then we're going to divide those. Now this is going to require some just basic fraction computations. So if you have your unit circle, you might want to pull that out right now. Huh?
Those little things, the square and pi over 2.
Here?
Yeah.
That's pi over 4.
No, I mean for the thing.
It's square root of 2 over 2.
What did I say?
You said pi over 2. It's square root of 2, yeah. So pi over 4 is one of the middle ones. So both the x and the y are square root of 2 over 2. So if we're going to find tangent of pi over 4, we do sine divided by cosine. Now remember in fractions, keep, change, flip. So if we're doing the square root of 2 over 2 divided by this fraction, that's the same thing as doing times 2 over the square root of 2. Now, this specific one, you could have recognized these are the exact same thing. If you divide something by itself, it's going to equal 1. But when you do it this way, you have 2 square root of 2 over 2 square root of 2, which equals 1. So the tangent of pi over 4 is 1. Let's do tangent of 3 pi over 2. So we got to do sine of 3 pi over 2 and cosine 3 pi over 2. What is sine of 3 pi over 2? -1. It's -1. So 3 pi over 2 is the one that's straight down. That's the point 0, -1. And so then cosine is 0. So tangent would be -1 divided by 0, which is undefined. Number 3, we're going to start with sine of 5 pi over 6, and then cosine of 5 pi over 6. What is sine of 5 pi over 6? That's cosine. Positive 1. Are you looking at a unit circle? Good job. Alright. And so tangent, we know we divide those, but they're fractions, so I'm going to go ahead and say, okay, keep, change, flip. So tangent of 5 pi over 6. I'm going to keep this one, change to multiplication, and then flip. Oops, I didn't flip. 2 over square root of 3. And it really doesn't matter, like if you put the negative in the top or in the front or in the bottom, just make sure you only have it once. So this would be -2 over 2 square root of 3. That answer is not wrong, but that's not how you will see it on a multiple choice question. If you remember, we did some examples previously with rationalizing the denominator, which means getting rid of a square root in the denominator. So if you have a multiple choice question, you're not probably going to see the square root here. Let me show you. So what you do is you multiply the top and the bottom by whatever square root is down there. And then on the top, that's just negative 2 square root of 3. Right. When you multiply square root of 3 times the square root of 3, that is the square root of 9, which is just plain old 3. So when you multiply square root of 3 times square root of 3, basically the square root just goes away. And it's 2 times, that's 2 times 3, which is 6. Like if you do square root of 5 times square root of 5, it's 5. Square root of 20 times the square root of 20 is 20. So square root of 3 is 3. And that 2 in the front made it 2 times 3. And this one can be simplified. The 2, 6. So it's negative square root of 3 over 3. So if you have tangent and it's one of like the 6th radian measures, it's going to be a little bit harder, a little bit more complicated, more steps to it. So we're going to kind of talk through tangent and what it is. So we're going to think of tangent in terms of the slope, as I said. So when we draw, like your unit circle has all those little lines, those are called the terminal rays. Each one of those, we can get a sine, cosine, tangent measure from. So if we start on the unit circle, and let's say that I'm starting with this right here. My radian measure is either 0 or 2 pi. What's the slope of that line? 0. So if we're going around the unit circle, the slope starts at 0. Okay. And then if I just kind of keep going, I'll get a ruler because I want straight lines. So as I go up the circle, what's happening to my slope? What's happening to the slope of this line as I go around the circle? It's getting bigger. It's increasing, right? The steeper your line in the positive direction, the bigger the slope is. So your slope, it starts at 0, and then it gets bigger until we get here. What's the slope of that line?
0.
The slope itself is undefined. If you have a vertical line, you say that the slope is undefined. So once it gets up to there, and that angle measure is pi over 2, the slope is undefined. And then I keep going around the circle. And so now my slope becomes negative. And then I'm running out of colors. I wanted all different colors. And then it's getting less steep, but it's negative. So like this might be a slope of -3. This might be a slope of -1/2. So it's going from like big negatives, so big negative numbers, to smaller. So it gets down there. And then once we get back over here, What's that slope? Back at 0. So once we get an angle of pi, we're back to a slope of 0 again. And that's, so remember, slope, tangent is the slope. So your tangent is going to start at 0. It's going to get bigger, 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 and then it's undefined, and then it's going to start going into the negatives. Now, as soon as we pass the angle pi, the slope will be the same as it was up here. So do you agree if I extend this line, does the slope change? No, it's the same. It's the same line. It's the same slope. Same thing here. And then it's the same. Then it's going to be undefined. And then that's why I wanted a ruler. So if I color it, it's going blue, pink, green, orange, purple. And then it starts over. Blue, pink, green, orange, purple. So I colored all the lines different colors. So what's happening is once you hit pi, once you go halfway around the circle, tangent starts to be repeating again. So in this blank it says the slope will be the same as it was in quadrant 1. So it's back. So once you hit here, it's back to being the same as quadrant 1. So it doesn't take it going all the way around the circle before tangent starts to repeat again. All right, it starts every half revolution of the circle. The tangent starts to repeat again, which means the period is not 2 pi. If it starts repeating halfway around, what would the period be?
Pi.
Just pi. It would be half of 2 pi. So the period of tangent is pi. Now we discussed that cosine cannot be 0. That makes it undefined. So when cosine is 0, we have it undefined. That's what we call a vertical asymptote. So let's go ahead and fill that in here. Vertical asymptotes. And so we know with just normal tangent, that's going to happen at the angle that's straight up or the angle that's straight down. So what are those 2 radian measures? The one that's straight up, the one that's straight down. On the unit circle. What's the pi over 2 and
3 pi over 2.
And 3 pi over 2. So pi over 2, 3 pi over 2, it's going to be a vertical asymptote. But we know with trig, basically it just keeps going around and around and around and around, around a circle. So it's at pi, it's at 3 pi over 2, and then when you start repeating, basically you just keep adding, or subtracting pi. Because we know with periodic functions, we talk about when something's the period, every time you hit that period, it repeats. So if it's undefined, and then pi more, it's undefined, and then pi more, it's undefined, and then pi more, or going backwards, you can subtract pi. So when we're graphing it, we'll put our vertical asymptotes, but then every pi, which in this graph is 4 blocks, 4 blocks is pi, so every 4 blocks would be an asymptote, a vertical asymptote. So at pi over 2 and 3 pi over 2 And then if I counted 4 this way, or I could count 4 back. Keep counting 4 back. Yep. So if my graph extended, I would keep counting 4 blocks, because 4 blocks is represented by pi here. I just looked at the scale. So you have your main ones. I like to call those the main asymptotes. That's not mathematically the perfect way to say it, but the main asymptotes, and then you just add or subtract pi, or whatever your period is. But in plain old tangent, it is pi. So let's actually talk about those asymptotes. As we saw with sine or cosine, our equations aren't going to be just plain tangent of x. We're going to have transformations. We're going to have dilations. We're going to have things that change the graph, which means it's going to change our vertical asymptotes. It's going to change our period. So we know with sine and cosine, it was 2 pi over b, or 2 pi over the period. Well, what do you think tangent might be? It's going to be plain pi. To find like the period or find b, you're going to do pi over that, because the period is pi instead of 2 pi. So you have to remember that tangent of x, the period normally is pi. Okay. So to find the vertical asymptotes, so here we're really doing vertical asymptotes here. You need to know, what did I want to be here? Guess you need to know b, and the period, I guess, is what is supposed to go on those lengths. So if you're given an equation that is not just plain tangent of x, so it's tangent of some other number is there, you can say that period is pi over b.
Pardon this interruption. At this time, I need softball players to the front lobby. Softball players to the front lobby.
Just like we did with sine and cosine, it was 2 pi over b, or we could say 2 pi over period is going to give you b. It's the exact same, except instead of using 2 pi, we use pi because the period's different. And so now, here's kind of the new thing. A vertical asymptote occurs. So if you're just looking at an equation that is not plain tangent, it's pi over 2b plus or minus your period.
What made you so smiley about that?
Because it's just another like equation formula that you're going to have to remember. Yeah. And if you think about plain tangent, there's no b there. What is b of just tangent of x? What is b? Huh? If I give you this equation, what is b? What number is in front of theta, or your variable? What technical number? What? 1. So your b is 1. Okay, and we know that normal tangent, your vertical asymptotes are at like pi over 2. If you plug in a 1 there, it's going to be pi over 2. So if your b changes, that's going to change where your vertical asymptotes are. So here at number 4, if we have tangent of 2 theta, we're going to figure out where the vertical asymptotes are. So b is 2, right? if B is 2, what is the period? B is 2, what is period? Pi over 2. Because it's pi over B. And so we would say that we have vertical asymptotes at vertical asymptote. Oh, no.
I just wrote it because I looked really funny. It's all like,
The at symbol?
no, like the way you do capital V, capital A, and it's so smaller, it kind of looks like kind of logo.
Oh, no. So we have vertical asymptotes. It's pi over 2b. So 2 times 2. So pi over 4. But the vertical asymptotes keep repeating. So basically we just keep adding and adding and adding and adding and adding the period. Infinite number of times. You add pi over 2. If I wanted you to keep finding all of the asymptotes, you would be here adding pi over 2 until you died. So we're going to say pi over 2, and then we're going to put a k there. That's the formal official way to say that the first one or the main one or the easy one to find is at pi over 2, and then or pi over 4, sorry, and then I keep adding pi over 2 a whole bunch of times. And that's going to give you all the vertical asymptotes. You might see on a multiple choice question where the vertical asymptotes, I don't know, if you only have one that has pi over 4 there, that's probably going to be your answer.
So it's the one on top always going to say pi, and then the bottom is just going to keep going up by 2.
Well, like if I was actually finding the next vertical asymptote, so actually when I add fractions, that is not pi over 6. You have to have common denominators. So this would be 2 pi over 4. So the next vertical asymptote would be at 3 pi over 4. And then I would keep adding 2 pi over 4. And so then the next one would be 5 pi over 4.
Can you just think about how pi over 2 is also 2 pi over 4?
Yeah. Yeah, that's what you're doing. Yep. But they do want, like, this is the way that I've seen, like, maybe one question on, I've kind of scrolled through the mock exams that I have access to just to kind of get a glimpse at, like, how much, I really was looking at, like, how much Unit 3's on there to see what I could cut. But I do remember seeing questions where it's multiple choice. It asks you about the asymptotes, and this is like what the answer looks like. It's got the first vertical asymptote plus the period, and then there's a k there. So not really. I do, like, I think in general, like Unit 1, Unit 2, Unit 3 is going to be pretty equally dispersed. Like there you'll see a question that has a graph and just says what's the period and amplitude. Like those I think would be easy questions. If you got to remember period, which one's which. Period is this way, amplitude is this way. But there'll be some easy questions and then there'll be some tougher questions. All right. So remember, your goal is to get 21 is like the number of that's on the mock exam. That does not mean that's exactly what they're going to set it at, but I don't think that number is just hypothetically. I don't think there's like pulled that number out of nowhere. They probably really thought about it, and they're going to see how it goes and decide officially, but it'll probably be close. I mean, if you can get half of the questions right, you've got it. No biggie. So number 5. What is B? It is not 2. It's 2/3. It's 2/3. Yep. And so then the period is pi over 2/3. Pi divided by 2/3. So this would be pi over 1. If we do keep, change, flip, it would be pi times 3/2, which is 3 pi over 2. Okay. So we would have vertical asymptotes at so we would have pi over 2b, fractions. So that would be pi over 1, keep, change, flip, times, this would be, so that's 2 times 2/3 is really 4/3, so 3/4. So 3 pi over 4. So that's the main vertical asymptote, and then I add my period times k. Because you don't just add it once. You keep adding it, and you keep adding it, and you keep adding it, however many times, infinite number of times. Now, a lot of, with the equations, it's very similar. You're still going to have an A. We're not really going to refer to it as the amplitude, and the graphs of tangent look way different than sine and cosine. But still, that number, it is a vertical dilation. We don't refer to it technically as the amplitude. If it's negative, the graph is reflected across the x-axis. And then we have B. It's a horizontal dilation. And we know that from B we can get our period. It's pi over B. C is like the phase shift, just like it was before. It's a horizontal translation. It did make it way more complicated. Of negative c. So if it says plus 5, it's really moving left 5. And then D, again, it's not really called a midline. I might refer to it kind of as that, but you'll see with tangent, it's not really in the middle of anything because tangent goes up and down forever. So it is a vertical translation.
So build on each other, and if you didn't learn how to do that auto, then it's gonna be hard.
Yeah, but we might see, like, it might help you, like, as we keep doing more examples, then eventually maybe it'll click. Kind of like concave up, concave down, increasing at a decreasing rate. When we first taught it, it was like, this is so confusing, I don't get it, but as we kept doing it, most of you can, if you're looking at a graph, can tell me if it's concave up, concave down, increasing, decreasing, that kind of thing. So maybe it'll be the same way. So I had to reteach myself how to graph these. I've had to reteach myself a lot of things this year, just so you know. But that's normal for new AP teachers. So kind of here's how it's best to graph them. You're not going to actually have to graph them. It's going to be like sine and cosine, where you would be given a graph and 4 equations to pick from. Okay, but we're still going to graph it to start out. So the first thing we're going to do is find the period. So we're going to look at an equation, we're going to find the period. We're going to start with plain old tangent, and then we'll do some more. So in this equation, my b is 1. Which means my, if I could spell, my period is of tangent is pi over b. So it's pi. We've talked about the period of tangent is pi. Halfway around the circle, it starts repeating. Now, we're just going to kind of stop there. Next, we're going to figure out what the main vertical asymptote is. Okay, and you probably, especially on more complicated ones, you're going to need a little pencil. So we're going to sketch that one in pencil first. So vertical asymptote at pi over 2b, which is pi over 2. So I would sketch in a vertical asymptote at pi over 2. Now here, and then let's see. Okay, so now I would look, if I had a C value that moves it left or right, I would take this vertical asymptote and shift it left or right before I officially drew it in. The thing is, we don't have that. So this is going to be your, so I'm going to go ahead and put that back in here. But sometimes we'll have to move them, so that's why I want you to do it in pencil first. And so that I have another asymptote every time I hit pi. And you can just look at your blocks. If you look right here, you can tell that 4 blocks is pi. So I'm going to count over 4 blocks and do an asymptote. 4 blocks, asymptote. 4 blocks, asymptote. We're going to get our asymptotes in first, and then we're going to look at D, which is, we might refer to that as the midline because that's what it was for sine and cosine. It's not really in the middle of anything, but technically, so with your pencil, you would real lightly sketch that. On tangent, it's a 0 because I'm not adding or subtracting anything. Okay. we're never going to officially draw that in. So that would be real light no matter what. So we're going to get 3. So tangent does this. Goes like that a bunch of times. Okay, and so we're going to like start with between one section. I'm going to start right here. And you're going to put on the midline, you're going to put 1 point in the very center. So if my midline was up here at 2, I would put the point up there. And then you're going to look at your A value. In this case, it's 1. A is 1. So I'm going to go halfway between these two and count up 1, halfway between these two and count down 1. If A is positive, your 3 dots should kind of be going uphill. If A is negative, you would do it backwards and your 3 dots would be going downhill. And then we sketch it in, and this is what it looks like. And I always have trouble drawing them. It's like it wiggles in the middle. And then you're going to repeat that between every vertical asymptote. For some reason, it's easier for me to draw in the little wiggle in the middle and then do the other parts. That's what tangent looks like. I'm not like super worried about how they look. If I can see where your points are and see that you've either got them going up or down the right direction and your curves look really wonky, that's okay. Alright, so number 8. What is B? It's 1. Yep. So the period is pi over 1, which is just pi. So my starting vertical asymptote, I will start with pi over 2b. Pi over 2. And that's the one I'm going to draw in pencil. Okay, so that's kind of where I think that a vertical asymptote would start if I did not have a phase shift. Do I have a phase shift? Yes. That phase shift is pi over 2. So it's going to move left, does the opposite. It's going to move left pi over 2. And how many blocks is pi over 2? 2 blocks. So this one right here is going to move over 2 blocks. It's going to move to right here. So then I don't need this anymore. Really, you would not have to draw that in pencil. You could just think, okay, I start here and I move left 2 blocks. I want to visually show everything. And then my period is pi. How many blocks is pi? 4 blocks. So I'm going to count over 4 blocks. And I've got another vertical asymptote. 4 blocks, asymptote. And then go each direction. Now I also have that -1 at the end, which means when I do my point, so your middle if it goes in down forever, you really can't, but it's where the wiggle is. And then to the right, I'm going to count up 2 because notes. There we go. So there. So that one's not pretty. Do what? Yeah, it's bad, but it's okay. So we will be in